Hello, everyone. Welcome to my talk about service workers. Thanks for coming out today, and thank you for all the sponsors who have helped put this on, and the organizers as well. My name is Kat Fairbanks. I am working at a company called Generate, working on CAD software for architects to design buildings more efficiently. I'm also a Cincinnati community organizer. I'm working on the Momentum Developer Conference, as well as Cincinnati Software Craftsmanship Meetup Group that meets monthly, starting again here soon. So I've been a full-stack developer for about 10 years now, working a lot with the web in a lot of different industries, including warehousing and manufacturing on single-page apps. And in warehouses, if you can think about it, you're surrounded by all of this metal racking and tools, and it makes Wi-Fi really hard to access consistently throughout the building. And so when working on web projects in this environment, we need to be able to access our things offline. And so there are a few options for how you might want to do this, but my groups have typically been smaller. We don't have a lot of native application developers. And we want to work with the tools that we already know. So JavaScript is a great tool for this, and it ends up being the hammer I reach for most often, just because that's what my teams are most familiar with. You can do things like Electron, other native S things, but being able to do this on the web allows you to use the deployment tools and the frameworks that you already know. And service workers add the ability to allow offline access to those sites. So to get started, what are service workers? They are a special kind of web worker, and that means that they're running on a separate thread from the main page in the background. And service workers are extra special in that they may be running even when the page isn't open in the browser. They're designed to do background processing, so they're great for things like push notifications that might be coming in at any time, even when you're not actively on the site. They also have built in the ability to act as a proxy between a web page and the network. This gives you a ton of power, and because you can decide how you want to respond to network requests directly using either cache data or building something entirely new. So what we typically end up seeing is that you want to pre-fetch and cache your data, and this can happen in the background. You will either improve application performance, or you can access web pages offline entirely. One thing to note before you do get started with service workers is that they are only available in secure browsing contexts. So this is maybe less important nowadays because you can do things like deploy to GitHub or other test sites and have access to the HTTPS. But you need to be in that mode, no HTTP. But a local host is a special case to allow for easy development. Some real-world examples of sites that use service workers for offline access are things like Excalidraw, which I've used in this presentation to draw some of the diagrams. Regex 101, if you're ever struggling with what a regex does, you can access that site offline if you need to, as long as you visit either of these pages once while online. YouTube is a huge example. If you pay for premium, they unlock this feature that allows you to download videos and view them offline. And this is not only in their mobile app, but they also allow you to do this in the browser, which I think is really cool. Spotify as well has an offline shell. And you'll see this off and on, where you get different amounts of functionality while offline. But if you can get access to the data you need, or just a minimal amount, It can be super useful if there's like a power outage, something like that. You can still update like your Google Docs, your Google Slides, and still be productive. There are fewer examples that I was able to find of sites that are using this just for caching and no offline access. Kroger was an interesting one that does use it to cache all the images on their site, which makes a lot of sense because they're a marketplace. They're very image heavy. And so a lot of their marketing images that they use seasonally are actually cached on your browser. So if you're a Kroger customer, after this talk, open up the dev tools and see like what they've put on your computer and have stored for like years. It's actually really interesting to start digging into that and seeing what other people are doing. So getting started with service workers is super easy. In your main script for your app, where you put in your application code, things like that, you can just call navigator.serviceworker.register and give it the path to your service worker script. And this will tell the browser, hey, this is my service worker, use it if it already exists, or go download it and install it. And the browser kind of just takes it from there, makes it very simple for you. This starts kicking off what is the service worker lifecycle. So it starts with that register, and then it will send the service worker events. Like I mentioned before, service workers are in another thread, so they don't have access to things that are synchronous, so like the DOM or local storage, things like that. And all the communication to the service worker is primarily event-based. So the very first thing you'll get is an install event, where you are expected to do any preparations to get your service worker ready to control the page. Once you have done that successfully, it will stay in the waiting stage until your service worker is ready to until the browser is ready for you to control the page, where your service worker will be marked as activated with the activate event. If your service worker fails in any way, like the script fails or it wasn't able to download everything it needs, it will go into the error state and it won't start taking over the page. It won't try to install over an already successfully running service worker. One thing to note is service worker scope determines what it can control. So by control, I mean what pages, which paths it can control, like the fetch events and things like that for. By default, the service worker is allowed to control any paths within its directory, so if you want to organize your scripts, like scripts/service worker, this can cause problems because it will only control things like the scripts, anything within that folder. It will not control the root site by default. And it's not allowed to without a little bit of extra work telling the browser that the main page is OK with that happening. The service worker has a lot of access, right? So it's getting all of those fetch events. You want to make sure this is done securely. So another issue that you can run into is that only one service worker per scope is allowed to be installed. So you may seem like, oh, I can make different service workers for different paths. It's great until you want to control the root site and they start conflicting with each other. So in almost all cases, you'll want to just store your service worker script in the root path so that you get control of the whole site, and then you can use JavaScript logic to make different functionality from there. So this lifecycle thing is probably one of the hardest concepts to understand about service workers, and I've never been able to understand it from the diagrams myself. So I want to go through a quick demo of what this looks like in the dev tools, because I feel like this will help you understand it better and show you how to debug issues with the lifecycle itself. So to get started, yeah, OK, that's big enough. So I have our main.js script, and so that's what is running in the browser and would be where the rest of your application code would be. What I have here is it's logging the current status of the service worker, and it's calling the register function. I'm using scopes in these demos just to make it easier to collect all of the code in one place, but it's at the root for each demo. You can do other things from the main script to see if there's a service worker controlling the page or seeing when a new one gets activated. There's an on-controller change event. And you can also call navigator.serviceworker.controller to get a reference to the current service worker. So now that we've registered our service worker, let's look at it. So we have a version that we'll use in a second to show what updating is like. But to get started, we are registering 2 event listeners, one for the install event, and then another for the activate event. They're just going to print out messages to show when this happens as we get started, and it will be a little more helpful later. So when we go to this demo, this will be the first time I visited this page in this browser. And we'll see pretty much immediately the service worker has gone through the entire lifecycle and has both installed and activated. There were no other service workers in the way, so it just immediately jumps into action. This is the Chrome developer tools, but I think Firefox's look pretty similar. And if you go to the application tab here and the service workers section in application, you can get a lot of debug information about the service workers. This will show all of the service workers for a given domain, and it will show you the scope of the service worker here. You can activate certain events like trying to trigger an update, unregister it entirely, and it will show you a kind of a version number so you can track what updates are, as well as the current status, and does a lot of other things as far as giving you analytics on how fast this is happening. But the more interesting thing is updates. So whenever this service worker file changes, and the browser's trying to do a byte difference of the file, it will try to get this service worker on refresh. So I'm going to press Control R here, and you'll see it had the original service worker already installed. It called register, and it went and fetched the new version, and it's waiting to update. So the version 2 of the script will just sit here until I either navigate away from the page or leave entirely and come visit back. It's interesting, something that really tripped me up when I got started is a simple refresh I thought of as a navigation event, but that is not enough for service workers because of how the browser works. It's going to use the cache version from the event 11. And so this, I think, has caused me so much pain, and I did not know that until I started preparing this talk. So if I hit the back button, you'll actually see immediately it updated because I navigated away, and it's ready to completely control that path. This gets even more wild if you have 2 tabs open. So this is called like 2 clients is usually, I think, how it's referred. So if I close the DevTools and reopen them, they are updated. You can see I have 2 clients listed here, and I can click Focus to see what they are. And so if I go to update the service worker, it's version 3, and I hit refresh, it will download it. It's waiting to activate, but the back button no longer updates it, because this client's still active. It wants the exact same, it doesn't want the underlying service worker version to change for any client, which this is funny because on my phone, I will have like 5 versions of a site, or even on my desktop, there will be that one Chrome window I've minimized and it's been open for 3 weeks. And this has bitten me more than once as well, not understanding why this was happening. So there are a few ways to get around this. You can see in the dev tools, you can just click skip waiting, and it will install the service worker. You are able to do that programmatically as well. In the install event, if you uncomment this line of code and update the version, it won't wait any longer. I can refresh, and it will automatically update the service worker for me. So we'll see it went from 13 to 14 without that waiting step. And if you're worried about maybe the different clients being run on different versions, you can say clients.claim during the activate step, and that will kind of force everything to be put on the same version, the latest version. And so that's the major points for the life cycle and updating. If you've got that, you're probably going to have a good time with service workers. It's definitely the info I wish I had when I got started. And now that we have that, we can start talking about actually intercepting those network requests and enabling offline functionality. So this is done by adding an event listener to the fetch event in your service worker. So this event is called anytime the browser makes a network request. You'll get the event with the request object on it, and you can call event.respondWith, which takes a promise of the response you want to use for that request. If you don't call event.respondWith, the browser will continue as normal and use its normal network request flow. So there's a lot of possibilities that we have here when it comes to figuring out what kind of response object we want to use. So you can make a network request yourself within the service worker and just return that result. That's probably the simplest way to do it, and that's what I have shown here. You just say respond with fetch, pass it the request, and continue on. But this isn't very useful. You're just re-implementing the browser's functionality. But you can also create new responses from static data, IndexedDB, or some other kind of source. I think I've seen people talk about doing like templating within the service worker, which sounds interesting. Or you can use a response stored in a cache using the cache API. So in the service worker spec, they've defined a cache API that is a long-term storage solution for request and response object pairs. So it fits this use case perfectly. Something that's kind of interesting to me is that this is available from both the service worker and browser contexts. I don't know what you'd use it in the browser context for, but if anyone has any ideas of fun things we can do with it, let me know. I like to do fun things with code that aren't supposed to be done. The amount you can store in the cache API depends on the browser. It varies quite a bit. Typically, you'll see that it is based on the amount of storage you have remaining on your disk. And I think Safari will actually give you a certain amount and then ask the user if you're allowed to have any more. If you use all of your space and you need more, the browser is allowed to just completely clean it up and throw it all away or keep it all. It can't do like least recently used or anything for you. You are responsible for cleaning up anything unneeded in your cache and managing the size of it. So to interact with the cache, you start with the caches keyword in JavaScript, and you can say caches.open has delete, and it takes a cache key that gets you a reference to new cache or an existing cache for caches.open. Has just tells you if it's present. Delete, you can get rid of old caches, and so that's a recommended way to clean up old data is by using a version number in that cache key. And if you need to iterate over all of the caches that you have, you can call caches.keys and see if what you need and what's there that doesn't match your current dependencies and clean those up. To put items in that cache object once you have it, they have provided this caches.add method that can take a path, a URL object, or a request object, and it will conveniently go and fetch this and store the response in the cache for you, which feels pretty magical. And they have an add all version of this where you can pass in an array of those kinds of objects and get a bunch of assets all at once and cache them. And so this is what you typically do when you want to cache an entire website is in the install event, do cache.addAll, and then you'll have a complete copy of your website downloaded in the background, ready for you to use in your service worker to be able to serve that site offline. Once you have all of that stuff in your cache, you need to go get it back out. So we'll have cache.match, and you can pass it the same kind of request or string, and it will try to find a request that matches that path. It will return a response object if it found anything, or undefined if it did not. It won't reject the promise like you might expect. The promise will always resolve successfully. So once you have those two things, we can put it all together, and you can use event.respondWith to handle request and open your cache, find the response that matches for that request, return if it exists, and then to handle this gracefully, if you don't have it cached, attempt the network request so that the user doesn't really know anything special happened. It should act just like viewing a normal site. So we have a demo of this as well to show how this is working and how you can use the developer tools to see what's going on. So from here on out, the main JavaScript is very simple. It's just going to do the register call, so we won't look at that again. But the service worker has a lot more going on. So like I mentioned before, using a cache version is one of the best practices. This makes it easy to completely wipe out the cache if you don't need it anymore or need to change it for some reason. We have our install event, and we want to call event.waitUntil. So this is important so that we want to make sure that we have successfully fetched all of the assets we need to serve the website offline before the service worker is installed and activated. So we are calling event.waitUntil. It takes a promise. So I've got an async function here that we're calling to go fetch those assets. So we get a reference to our cache using caches.open, and then we're going to call cache.addAll and list out the assets that I need to serve this site offline. As long as this promise resolves successfully and it was able to fetch all of those assets, the service worker will be installed and then eventually activated as part of the lifecycle. Something interesting to note here is that you'll see I've got 2 entries for the main page of this site. You want to include anything any possible path the user might use to access that page. So there may be duplication there. Depending on how you expect the user to browse your site, if they're going to be messing in the URL bar or something like that, you might want to include both of these. In the activate step, we've updated a little bit as well. We want to delete the old caches for our app to make sure that we're responsibly cleaning up everything when we're done. So this is using the cache keys method and iterating through all of the caches that are available for this service worker. Something that I found out during these demos, having service workers on multiple paths for the same domain, is that I could access the caches for my other demos from this one, and they started cleaning up after each other. That was unfortunate. So be careful if you're ever in that situation, and also be thinking about security and things like that of who has access to what data when you're using this. So iterating over all of the cache keys and checking if it starts with our demo number, and then deleting it if it does, but it's not one of our current cache keys. And finally, the fetch event is what we saw on the slides earlier. We have the response with to tell the browser, hey, I'm taking over here, and we'll handle the request. We're getting a reference to the cache, trying to find the response, and if it's there, return it, and otherwise make the network request as normal. So if we go to look at this example, we'll see, OK, I've got my service worker for 02 over here. This is a simple site with 2 pages and 2 images. You can see in the console, I'm logging every time we return a cached response here. So it's going to be serving both the index and the image. And to use the dev tools to kind of prove that we are actually able to serve this page offline now, you can use this very handy offline checkbox. And this will simulate as if we are offline. So if I click these buttons, it's still looking all the same. And you can't really tell that you're offline. The site's fully working. But if you want to see that we're truly offline, if I hit the go back home, it's going to say that I have no internet. So everything's working as expected here. One thing to note is that sometimes this checkbox in this network setting will become unsynced, and it will say you're online, but you're not, and you'll wonder what happened. So be careful. Thankfully, they put a little warning sign here to tell you that these network settings have changed, and you might want to watch out. So that was much easier than lifecycle. It's fairly easy to handle basic requests using these caching tools. But we can do more with it as well. So we can add responses to the cache dynamically. So at runtime, so in the previous example, we cached everything up front. But images are pretty big. Access patterns to your site may not mean that you want all of those images downloaded up front and taking up all of that space on the user's machine. So doing it at caching images at runtime may be a more appropriate way to handle those sorts of requests. So in this example, in my handle request method, I have a check to see if it's image path. And if it is, I will make the fetch request the first time, open a cache, and put the response for that image in the cache and return it. Otherwise, I will refetch the asset normally. And so this lets me only cache the images the user has seen so far, and maybe I'll want to handle something else differently. There's a lot of different caching patterns that we can use. So far, we've seen that we can do cache and then falling back to the network if it's not in the cache. So if the page makes the request, service worker checks the cache first, and if it's not there, it will go to the network, get it, and optionally store it in the cache for later use. There's even more simpler patterns than that, though. You can just say, I'm only checking the cache. This is probably not very appropriate for most things. You might want to do that for the app shell where you're not expecting it to be accessed by anything else. But for the most part, you don't need this pattern. But the other simple cache, request pattern would be network only. And this one is actually very important. You don't want to cache everything. If you're talking about like put requests, anything you're trying to make mutations on the server, or you're trying to send data to the server, caching that is going to block requests and make your application not work anymore. You do need to have some network-only functionality for everything to work right. So make sure you're being very careful about what things are being cached. Another pattern you can use is starting with a network and falling back to the cache if needed. This is really good for things that are changing frequently. So if you've got kind of live data and you want to be as up-to-date as possible, like a news feed, something like that, you might always want to try to go to the network, but then fall back to the latest version that the user was able to get successfully, so they can at least continue to use your app and see things. So this is something you would say you'd want to use for like Gmail or something like that, where you want access to some of that data. You can also just try both and let them race. There's kind of a million different things you can do with these tools. So it's up to you to decide what patterns are most appropriate for your situation. And there's lots more things that are written about it that can tell you when you might want to use different little subtle things to tweak this. One last thing that we'll add in this next demo is using a generic fallback response. So I think I hinted at this earlier. You may want to do templating, something else. Maybe for those images, like we were talking about, we want to show something when you're offline, but maybe not the exact image. So the page can make the request, check the cache, check the network, it's nowhere to be found. Return something else. Make it look nice still to the user, keep the user experience nicer, and make things as good as possible when you're offline. So let's take a look at some of these caching strategies and how to put them together in an app. So here I've got two different caches. You're not limited to using only a single cache, and this can be useful if you're using multiple caching patterns to kind of keep things straight, understand which ones maybe you're going to clear out old data from, like the images, whereas the pre-cached ones are absolutely essential to serving your site offline. The install event is the same, where we're just grabbing everything we need for the application shell and making sure that's all available all the time for this version of the service worker. Activate, again, also the same, where it's going to clean up everything, and then the fetch handler has changed a fair bit. So at the beginning, we're going to start with trying to find a response in any of the caches. This API knows that you want to possibly use multiple caches, so they've provided a caches.match request. And so this actually goes and checks all of the caches you have available for a response and returns it if it found a match. And so this can be very helpful when you've got a lot of different caches acting differently. You only need one function call to try to match them all. And if the response was not in any of those caches, we are going to fetch the resource from the network. So we're going to use await here, get the fetch response, and check if this was an image request. We could probably do a better check for that, but I know exactly what my app's doing. I don't need anything more complicated than this. It's a regex. It's complicated enough. So if it matches that, it was an image, we're going to get a reference to our image cache and put that response into the cache. But either way, if it was an image or not, we still need to return a response to the browser. So we're going to return that fetch response. If we were not able to make this fetch request successfully because we're using async await, it's going to throw an error. And so we're going to catch that error. Again, test if it's an image. And if it is, we're going to use a placeholder that we grabbed during the install step in our prefetched assets and return that instead to try to give the user something and fill that spot. So if we look at the demo here, I don't know why I keep trying to use the back button. And demo 3, we have a site, and we've got a description and the image here. There's 3 different pages. If I go to page 2, why? My browser's been acting funny lately. The image is there. So it was able to find the image. Ew. You are very unhappy. I have had a little trouble with these service workers wanting to step on each other, even though they're on different scopes. So I'm going to unregister the other 2 to make sure there's no interference, and that should have us going better. So we've got 03, we're seeing the image, we're seeing the second, okay, we're good now. So if I go offline at this point, we haven't looked at the 3rd page yet. If I go to page 1, we've seen the image, it's going to be served. But if we go to page 3, it will show image not available. It's showing my placeholder image instead. So as you can imagine, trying to understand what's going on with these network requests can get really complicated. And thankfully, Chrome is generally pretty helpful with us. If we go into our network tab, you'll see it's grabbing the page here, grabbing all of our stuff, and it's actually going to write down that it grabbed this from the service worker. And so it will say it's trying to get the image, but the service worker made this request. And the requests the server worker makes are prefixed with this little gear here. And this one failed, right? So this request that the browser thinks was successful, if I go to the preview, it will show my placeholder image instead. So this is completely transparent to the main HTML, the main JavaScript, that the service worker is doing all of this massaging for us with the network. It just thinks everything's working like normal. It's pretty happy. And if I were to go back online and hit back, it will be able to load that image again. Another thing to look at when you're dealing with the cache and dealing with images, trying to understand what has been cached and what hasn't been cached, is you can go into the application tab again and jump into cache storage, and it will actually list out all of the caches that you have opened on this domain and that the service workers have access to. And if you go to click on one of these, it will actually list out all of the files. You can preview them, see what they are, see when they were downloaded, and if you ever run into issues, you can kind of also debug this way, seeing what's happening. So if I were to delete that image, I can just delete all of these. So if I delete these and go back offline, you'll see that it will start showing the placeholder again. So this is really useful when you're trying to test different scenarios and set up something that's maybe happening on a user's machine that you aren't sure why it's behaving the way it is. You get a lot of insight into what's actually going on through these developer tools. Okay, and so that is the main concepts used to build up these service workers. And this is a lot to manage on your own. There's a lot of moving parts. There's a lot of different patterns. And people have made projects to make this way easier for you. So Google's Workbox toolset is probably the most commonly used tool to make projects using more advanced service worker patterns. And it's pretty easy to use, very easy to get started, but you don't even need to start there. You can start by using a plugin that's available for the mini build tools and frameworks that is pretty much just plug and play with a few lines of code. There are tools available for things like Vite, Webpack, Rollup, Gatsby, Next, and Nuxt, and they make it super easy to get started. But they don't really equip you with the knowledge to be able to debug these things successfully. And so that's where I think I started running into problems, and why I'm giving this talk today. So things to keep in mind if you do want to start using caching for your projects, consider how frequently the items in your cache might change. For JavaScript, I think you'll typically see us wanting to add like a hash after file names so that any one file name is going to be directly correspond to one version of a file. So that makes sure that we're not getting stale things in the cache and can't update them correctly. But how do we update or clean up those stale assets? So when you install that service worker, that's usually the easiest way for your application shell. The service worker is going to change because all the file names have changed. You clean up the old cache as part of the install, and all of those plugins will pretty much just do that for you. And then another thing to consider, how much do you actually want to cache? That impacts how much storage is needed, how long it takes to install the service worker if you're downloading a bunch of files into the pre-cache. So it may take 10 seconds to get all of the images and JavaScript and everything you need to run the site successfully. So keep that in mind when you start to use service workers. Larger files may not be appropriate for the pre-cache. You want to only do that at runtime. And another thing, is it worth the performance impact? So using service workers to manage those network events, it's adding another layer of code, and that's going to add more time to the response. So it's a delicate balance for especially small files that are probably going to come back very quickly. You may not want to cache those things if you're not trying to use it offline. And there are a lot of ways this can go wrong. If you can imagine cache things, caching always adds fun problems to a project. So the biggest one I run into regularly is do not register it in development unless you are actively working on the service worker. You will wonder why none of your updates are making it to the browser for longer than you should be. So yes, keep an eye on that if you know you're working on a project that does have a service worker. Make sure you're unregistering it as soon as you're done and don't install it. Most tool sets will not install it in dev already for you. So they try to protect you from yourself. Another weird thing that I didn't quite realize is that the service worker can be shut down. That thread can be shut down at any time by the browser if it's not actively handling an event. So don't store any state or things like that in variables inside of that script file outside of the events because you don't know when that service worker is going to be stopped and started again. The reason this is very odd is that it will always stay running when your developer tools are active. So it's going to act very differently in development than it does in production. So keep that in mind. When you're testing things, you may want to have your developer tools closed most of the time, so you're closer to a real user's machine during testing. Another weird thing that I learned in production is changing the service worker file name is really tricky. Because it's serving that cached index, it's serving the cached service worker name. And so you end up in this loop. And it can be quite a pain, but you can do it if absolutely necessary. So if you're changing build tools, for instance, and you want to stick with the service worker name that comes by default, so it's going to change a little bit. You can use a self-destroying service worker if needed, and you can get around that. But keep that in mind. Try to pick one name and stick with it. Another thing is that caching more complex files, like audio and video, like YouTube is doing, can be really challenging. They don't actually end up using the cache API for those video files because they are downloaded in bits, little chunks, using range requests. So they have a lot of code to make this happen and work successfully. And they thankfully have a live demo with how they're actually doing this for YouTube, available with source code, kind of demonstrating what they're doing with that using indexed DB. And one last thing, making cross-origin requests in no course mode results in an opaque response. And we might be familiar with that by making these in JavaScript already. But it's especially important to note when using service workers and caching, because you have no way to see if that response was successful or not. You don't get access to the status code or anything like that. So by default, most libraries will outright ignore these requests and not cache them. So if you need that asset to be cached and it's a cross-origin request, you need to use cores to be able to get that insight. And finally, a few tips and tricks to leave you with that I've found over the years. If you're working on multiple sites locally, you can, with I think just Chrome and Firefox and the Chromium family, you can actually prefix the localhost domain, and you can get unlimited unique domains pointing at your local machine. You still need to add the port number afterwards like you normally would, but this can help get you isolation between those service workers for the different sites. And this can be really helpful for simulating cookies on different subdomains as well. Another thing is force reloading. So that's a shift, refresh, whatever that refresh keystroke is for your operating system. That will cause the browser to bypass the service worker entirely and load the page as being uncontrolled by the service worker. That sounds really great for development until it tricks you into thinking everything's working correctly. So it's a great tool to validate some things, but make sure you're not confusing yourself and thinking everything's OK, because I think I normally refresh sites using force refresh at this point to make sure the cache is cleared during development. There are also additional developer tools for looking into service workers. I want to make sure we have time for questions, so I don't want to pull them up live here. But you can look at Chrome Service Worker Internals, DevTools, that will show you all of the service workers that are installed on your machine with extra debug info, if they're running, versions, things like that. And it could be really interesting to see how many sites you visited over the lifetime of a machine that have installed service workers. I didn't actually make it through the whole list on my personal account. Another interesting page is you can inspect service workers, and it will show you all of the currently running service workers, and you can open their DevTools in a completely separate window to observe them as well. All of these things can give you little different insights into what's going on in your machine and maybe help you debug other issues. And that is all I had for this talk. If you want, I have all of these resources up on GitHub with additional links to other sites that talk about service workers, these caching patterns, and everything like that. There's the QR code there. It's also up in Discord as well. Thank you all for coming. If you have any questions, feel free to ask in Discord. Hit me up on social media. I'd love to talk about all things tech, community, and I'm getting really into lots of interesting web stuff with like background processing. So if there's anything you're working with that's involving service workers, web workers, and that kind of stuff, I'd love to hear more about it and hear about your use cases and the situations you're running into. So with that, are there any questions? Do I know of any other libraries other than Workbox? I do not personally. So what I'm using right now is Veet's Progressive Web App plugin, which I know is built on top of Workbox. I used the Create React app one as well at one point, also built on top of Workbox. So yeah, I don't think I've seen any others besides just rolling around. OK, so on Discord, someone asked if it's in plain text. I don't know. I know they've done some obfuscation of things. One thing I did see was that the size of these responses can be obfuscated because they don't want you to use this for like fingerprinting and tracking people, which suddenly made me very concerned to hear about. But you should treat it as if it's in plain text. You're able to access that response object like you would in JavaScript. So you shouldn't have anything sensitive in there that you wouldn't want other people to access. Someone asked what editor I'm using and how did I get it into Vim mode. I'm using VS Code with I think a Vim mode plugin. So I don't know why I started doing that. I think I was trying to learn how to use my coworkers' machines, and they liked Vim, so I had to like Vim to be able to work with them, and it stuck. So OK, if there's no other questions, we'll end it here. Thank you very much.